All right, in this lesson, we're going to review isotopes and then begin talking about ions. So, quick review here. One of the most important things that we need to recognize is dealing with this first question here. What happens if you change the number of protons? And as you think about that, you should be thinking that every atom has a set number of protons. If you change the number of protons, the element will change. So as we study this, the number of protons cannot change. As soon as we change the number of protons, we will be changing the element. The second thing that we should be thinking about here, is it possible to change the number of neutrons? And the answer to that is yes. You can change the number of neutrons, and you're not going to be changing the element. It is still whatever element you began with. So if you're dealing with carbon, which has 6 protons, it's still carbon because we have 6 protons. The next thing we need to look at here is if you change the number of neutrons, what happens to the atomic mass? So dealing with that also, if you change the number of neutrons, the mass changes. And again, this should be review, so you shouldn't be having any big surprises there. A couple other things that we should look at. We have this right here. These numbers at the end each tell us something. Now if you look at it, each one of these is hydrogen. So right away we should start thinking about our protons. The protons are not changing. If you change the number of protons, you're changing the element. So obviously these numbers right here are not the atomic number. Instead, these are the atomic mass. Now, if you remember, the atomic mass is equal to protons plus neutrons. So each one of these elements has a different number of protons and neutrons. So again, if you're looking at these right here, this one would have 1 proton and 0 neutrons. You add those up, and you will get 1 for your atomic mass. This one's going to have 1 proton and 1 neutron. Again, this should be review. I'm not going to worry about the drawings on those. I should be fairly confident with this. Again, you can look up, once you have the symbol, you know what the element is. And we just talked about this. This second part right here is the atomic mass. The reason why I don't get the atomic number is because it never changes. Again, bromine is always going to be bromine. So if we look on the periodic table, bromine has an atomic number of 35. So that number is not going to be changing. So you can take a look there in your periodic tables, figure out your atomic number. Once you know that, it'll never change. The atomic mass, on the other hand, can. So each one of these is just a different isotope for that particular atom. So this one I would call that boron 11. This one I call lead 207, calcium 41. So that's kind of what we're looking at here with these. All right. Another way of looking at isotopes is something like this. It's really nice when you get everything right here. I don't need a periodic table for this because the top number is my atomic mass. Again, that's my protons plus neutrons. And the bottom number is my atomic number, which is equal to my number of protons. Typically, if it's a neutral atom, number of protons is equal to the number of electrons. So, to start off with, it's fine to think about that. If you look at these right here, now I don't need the atomic number. The atomic number isn't going to change. So I don't have to write it out. I don't even really have to tell you that. I can just assume that you can look that number up on the periodic table. So an easier way to write it is to do something like this. So I'm going to say the element fluorine 19. So fluorine 19, I know my atomic mass every single time. I can look at a different isotope of it, and I get fluorine 18. Again, I can write it like this, and this is a handy way of looking at it, but convenience-wise for writing it, this is much faster for most people. So, and we can assume that you can look it up again. Valence electrons are the electrons in the outer orbital. Once you start getting into bonding, this is crucially important that you can recognize your valence electrons. So the nice thing is that every group tends to have the same number of valence electrons. So if you look at group 1, they tend to have the same number. Group 2, we skip the middle part, so we skip to group 13. They tend to have the same things there. So one way of reporting those valence electrons is to do the electron dot diagram. Again, when you do your dots, the maximum number of dots you can have is 8. So we have one dot here, another dot here, and we want to spread them all out. So xenon, one of our noble gases, would have 8 valence electrons. Sodium, since it's in group 1, we put Na, it's got 1 dot. Chlorine is in group 17, so those particular elements have 7 valence electrons. So I'm going to spread my dots out, and I would get something like that. Sulfur, which is in group 16, has 6 valence electrons. So you want to spread those out and make sure everything is going okay there for you. So here's a chart just showing the elements that we'd be working with. If you look at it, every single one has 1 valence electron. Group 2, they all have 2 valence electrons. Group 13, they have 3 valence electrons. And we keep adding 1 valence electron until we get to group 18. At group 18, they have 8 valence electrons. So if you look at it, the maximum number of valence electrons any atom can have is 8. The minimum number is 1. Okay? Again, this should be review. All right, so this is something new here. We're going to talk about ions here. And again, the most important thing to remember, the number of protons determines